So the function that we're going to evaluate, you can go ahead and write is f of x equals 3x squared minus 2x plus 1. And we're just going to evaluate it for a bunch of different values, basically. So first, I want us to find f of 2. How do we find f of 2? Yeah, anywhere you see an x, you just put a 2 in its place. So I'm going to say 3, and then instead of saying times x squared, I'm going to say times 2 squared minus 2. Instead of multiplying it by x, I'm going to multiply it by 2, and then plus 1.
So basically just plug in.
So now the f of 2, you're not plugging that in a calculator. So you're not going to find a button that says f on it that you're supposed to use for that. This is just notation. This is exactly like saying y equals. So please don't plug anything in for that. But the right side, you can literally type that in exactly the way it looks onto your calculator. So go ahead and grab your calculator. I want everyone to type it in.
It's going to be 36 minus
What'd you say?
negative.
Yep. You want to bring me something to trade? All right, and what'd you guys get? 9. Marvelous.
I got cancer sticks.
All right. We're going to go ahead and do it again. This time we're going to evaluate it for negative 6. So same thing, we're writing it out. Just any place you saw an x, you're going to put a negative 6 in there instead. And what'd you guys get this time? 121. Okay. All right, are we good on the number ones? Evaluating with a number. These should not be much different from what you've done in the past. You guys should have done this before. Plug in something in. We are going to look at things where you're plugging in something other than just a plain old number. So somebody give me a letter. A. So this time we're going to evaluate the function for a. So what would that give us?
The same thing.
Yeah, the same thing, just with an a instead. So we'd say, oh, that's 3a squared minus 2a plus 1. That's it. Just take the x's, switch them with an a instead. That's
Does
all.
that really accomplish anything?
No.
No. Nope, sure doesn't.
Will we ever have to do that on a test?
No, I'm just introducing you to an idea so that we're going to do it more difficult in a second. You can kind of see. Just replaces it. Okay. Somebody give me a small number.
1.
2.
0.
Did you say y for a small number?
I said 1.
1. Oh, 1. Yeah, it's a pretty small number. Give me a letter.
J.
J. All right, this time we're going to do 2j. So what should I be writing?
3.
3, and then 2j is in parentheses being squared, right? Minus 2 times 2j plus 1. Okay. Now, if every single one of us tried to plug this into our calculator, we would all get a different answer. The reason for that is your calculator, do you guys see how your calculator has all these letters on it? Those letters are not to help you do these problems. Those letters are because your calculator can store numbers for you. So your calculator has a number stored in it as j, and if we were to type this in using j's, our calculator would use that number that was stored as j, and it would pop out an answer, and every single person's answer would be different because all your calculators have different numbers stored as j. So, yeah, so when we do these problems, we say if we're plugging in a number, we can use our calculator. If we are evaluating using an expression, this is an expression, now I've got variables and numbers, I cannot use my calculator. Do not use your calculator. Put your calculator off to the side. We have to do this by hand. I mean, just put it, no need to throw it. Just put it. So, we have to think about order of operations. Does anyone remember what the acronym is? PEMDAS. Now, if that calculator's broken, you know who's paying for that.
Me, it's my calculator.
Oh, perfect. Yeah. All right. So, order of operation tells us. The order of operation tells us the very first thing is we look to see if the inside of the parentheses can be simplified. Can you simplify 2j? No. Next, we're going to look at exponents. Do we have any exponents to take care of? Yes. We have a squared. What does squared mean? Twice. Yep, times itself. So we've got 3 multiplied by 2j multiplied by another 2j. I'm going to go ahead and write that out twice. Just because I find students get it right more often if they do that. The next step of order of operations is to multiply and divide and go from left to right when you do it. So right here we have 3 multiplied by 2j multiplied by 2j. So what do we get when we multiply those out?
6j
How come only the
times
2J's
12
double?
is 12j.
Yeah, so this is 6j. 6j multiplied by 2j is 12j squared. Perfect.
Why squared?
J times j is j squared.
Wait.
J times j is j squared.
We multiplied the 12.
3 times 2 times 2. All right, and then what about when you multiply these? Negative 4j, and we got the plus 1 on the end. The last thing we would do for order of operations is we would add and subtract if we had like terms. Do we have any like terms? No, so we're done. So that was it. So that's as much as you can simplify it. So we've been evaluating for all these problems, but you'll notice when you evaluate with an expression, you get an expression as an answer, right? A is an expression, so we get an expression. I'm evaluating with an expression, I get an expression as an answer. If I evaluate with a number, then I can get a single number as an answer. You guys see that? So just be careful. If you're evaluating with an expression, don't plug it in a calculator, you're going to get it wrong. All right? We're going to do one more. So this time we're going to do f of x plus 3. F of x plus 3. So this is an expression, right? That means our answer is going to be an expression. It also means we cannot use a calculator to do this for us. We have to do it by hand. So what should I be writing?
We're still doing good ones. Huh?
Yep, same f of x all the way through.
3 parentheses x plus 3 squared minus 2 parentheses x plus 3 plus 1.
So I saw the x in 2 places, and so I replaced the x in both of those places with an x plus 3. Alright. And we're doing order of operations. So is there anything inside the parentheses that can be fixed? Nope, x plus 3 is as simple as it gets. What do we do with our exponent? Yeah, but what did we do last time? Yeah, we wrote it twice. We said an exponent of 2 means that there's 2 of them, so I'll go ahead and write it twice. X plus 3 times x plus 3. Our next step is to multiply. Do you guys remember how we multiply 2 sets of parentheses like that? Foil, yeah. So when I start to FOIL, what do I get? I'm ignoring the 3 to start with. It's a little bit easier to FOIL first, so ignore the 3. So I've got x squared, because x times x. And then when I do the outside pieces, I've got x times 3 is 3x. When I do the inside pieces, I have 3 times x is another 3x. That's where we were hearing the 6x from the back. And then I've got 3 times 3, which is 9. So when we FOIL that out, we get x squared plus 6x plus 9. And I did not deal with this 3 in the front yet. So I got to keep that 3 in the front. How about this part over here? Distribute what? The -2. Yeah, make sure you take the negative with it when you distribute it. So we've got -2 times x, and -2 times 3 is -6. Good. And then we've got a +1 on the end. Are we done with our multiplying, dividing yet? We got one more thing to multiply, right? So let's go ahead and take that 3 and distribute the 3. What do we get? And I'll go ahead and drop down the stuff from above. Yeah, now we can do the adding and subtracting step and combine all of our like terms. Right, Corday? You texted that to your mom so she knows how to do it. All right, so what do I have?
Plus 16x plus 22.
Plus 16x, and then 27, and -6, and +1 is 22? Plus 22. So again, if you plug in an expression, if you evaluate it for an expression, you get an expression as an answer. Okay. How do we feel about evaluating? What do they basically mean when they say evaluate?
Simplify.
Plug it in. Plug it in and simplify. That's basically what they mean when they say evaluate. All right.